Okay, we're starting out with a warm-up on angles and quadrants, what we did yesterday. So we're told angle theta is in the second quadrant, and that the secant of angle theta, so the secant of angle theta is -3. And we know secant is the reciprocal of cos, so it's r over x. So we can fill in a 1 for x, but also we know r is always positive, so this negative sign should be down with the x. All right, so let's make a sketch. So we're told it's in the second quadrant. So remember from yesterday, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And we'll draw a terminal arm in the second quadrant. And our angle theta from the positive x-axis to the terminal arm. Choose a point along the terminal arm and then make a right angle triangle. Always towards the x-axis. So if we interpret this information that sec theta is -3, that tells us that x is -1 and r is +3, but we need to find the y value. So we can do that using our Pythagorean relationship. So we have 3 squared equals -1 squared plus y squared. So 9 equals 1 plus y squared. 8 is y squared. So then we have to look at our diagram to figure out whether it makes sense for y to be the positive square root of 8. Remember, we leave it as a square root if it's not a perfect square, or negative square root of 8. So since this is a positive y value, we should take y to be the positive square root of 8. So we sketched angle theta in standard position, done that, labeled all 3 sides and the angle, labeled the x and y axis. So now we have to determine the value of sine theta. So sine theta is the y value over the r value. So we've got sine theta right there. And then find the measure of angle theta. So to do that, we have to figure out how big angle alpha is. And then we know that theta is going to be 180 degrees minus alpha, because we're in the second quadrant. So this whole angle is 180. And then if we subtract alpha, we'll be left with theta. So then to get angle alpha, we look at this triangle and we can either redraw it, or if you can just do it in your head and pretend that all the sides are positive sides. So we can use grade 10 trigonometry in order to get angle alpha. We could use, if we don't want to use the square root in our calculator, we could use hypotenuse and adjacent and use cosine. So we'd have the cos of alpha is 1/3. Alpha is the cos inverse of 1/3, or alpha is approximately so 70.5, so approximately 71 degrees, which means theta is approximately 180 minus 71, 109 degrees. So again, that makes sense because it's between 90 and 180, greater than 90. And that's a lot of what we learned to do yesterday. So we're going to expand on that today. So today's lesson is called the cast rule. So our learning goal is that we're learning to use the cast rule to determine the possible quadrants the terminal arm of an angle could be in. So we're going to start off before we learn the cast rule and see how this problem works without the cast rule, and then how does the cast rule help us make the problem maybe a bit simpler. So consider the following problem. If the sine of theta is negative 2/5, find possible values of the cotangent of theta. So it's similar to the question we just did, but it does not give us a quadrant. Okay? So we have to kind of use our reasoning here, knowing that sine of theta is equal to, I'm going to write negative 2/5 because I know it's the y value over the r value, and r is always positive, which makes y have to be a negative number, or the negative has to go with the y value. So if we think about our 4 quadrants, there's 2 quadrants in which the y value would have to be negative, and that's quadrant 3 and quadrant 4. So we're going to draw a diagram for each of those possibilities. Notice how the question asks for possible values of the cotan of theta. So they're not just looking for one answer, they're looking for all of the answers that make sense. So here I have an x and a y axis, and here I have an x and a y axis. So it's possible to have sine theta be negative in quadrant 3. Also in quadrant 4. So theta could be drawn like this. Or drawn like this. So it could be an angle between 180 and 270, or an angle between 270 and 360. We're also told in each case, in each diagram, the y value is going to be negative 2. And the r value is going to be 5. And in either case, we don't know what the x value is, so we can use our Pythagorean relationship to figure that out. So we get that x is equal to positive or negative the square root of 21. So, and usually we would look at our diagram and say which one is it, positive or negative. But in this case, in this diagram, it makes sense that it's negative square root of 21. And in this diagram, it makes sense that it's positive square root of 21. Because in the third quadrant, both x and y are negative. And in the fourth quadrant, x is positive while y is negative. So now we have our 2 diagrams drawn and labeled. And now we want possible values of cotan theta. So if I look at this first diagram here, cotan theta, and I know my formulas, the x value over the y value. So the x value over the y value would be negative root 21 over negative 2, or that simplifies to just root 21 over 2. And in this diagram, the x value over the y value would be root 21 over negative 2, but I would move the negative to the top. So you can see that there's 2 different possibilities, and they just differ by sign. So I'd probably do like a therefore, since they're asking for the possible values. Cotan of theta is either positive or negative root 21 over 2. So there's 2 possible values that work. Okay, so the cast rule simplifies the process of deciding which quadrants are possible for a given question. Okay, so starting off, if we have our terminal arm in the first quadrant, so this is quadrant 1, and remember this is 0 degrees, 90 degrees, 180 degrees, 270 degrees. Up a little bit, 270 degrees. Okay, and then back to 360 degrees. So if we were in quadrant 1, we know that X, Y, and R are all positive. And if we look at sine of theta as being y over r, and cos of theta as being x over r, and the tangent of theta as being y value over the x value, y over r, if y and r are both positive, is going to be a positive. X over r is going to be a positive, and y over x is going to be a positive. So all the sine, cos, and tan ratios are all positive in quadrant 1, and that's where the A of the word cast fits in quadrant 1. Okay, in quadrant 2, you can see that x is negative, and y and r are both positive. R is always positive, and y is positive because you'd be going negative, for instance, -3, +5 to get into the second quadrant. So let's write out our sine, cos, and tan ratios again and analyze them. So y over r is sine, cos of theta is x over r, and tan of theta is y over x. So sine is going to be a positive divided by a positive, so it's going to be positive. X over r is going to be a negative divided by a positive, so it's going to be negative. And y over x is going to be a positive divided by a negative, which ends up being negative. So the only thing positive in the second quadrant, so this is quadrant 2, is sine. So that's where the S from the word cast comes in. So all three ratios are positive in the first quadrant, just sine is positive in the second quadrant. So in the third quadrant, x and y are negative, and r is positive because it's always positive. So sine of theta, again, is y over r. Cos of theta is x over r. Tan of theta is y over x. So if we think about that, we have a negative divided by a positive, so that's going to be a negative. X over r is another negative divided by a positive, negative again. Y over x is a negative divided by a negative, and we know a negative divided by a negative is a positive. So the only ratio that's positive in the third quadrant is tan. So that's where the T from the word cast comes in. This is the third quadrant. In the fourth quadrant, x is positive, and so is r, but y is negative. Sine we know is y over r, cos is x over r, and tan theta is y over x. So our y value is negative, our r value is positive, so sine is going to be negative. X is positive, and r is positive as well, so cos is going to be positive. And our y is negative divided by x, which is positive. Positive divided by negative is going to give us a negative. So the only thing positive in the fourth quadrant is cos. So we can think of the cast rule as telling us where the different trig functions are positive. But if it can tell you where things are positive, so I think of it as the word cast in this big positive sign, tells you where things are positive. But a ratio can only be positive or negative. So for instance, if sine is positive here, it means that cos and tan would be negative there. So it not only tells you where the different ratios are positive, it also tells you where they're negative. Again, C stands for cosine is positive, A, all of them are positive, S, sine is positive, and T, tan is positive. So how's that going to help us? So we're going to try a question here. using the cast rule. So given that the cosine of angle theta is negative 7/25, determine which quadrants it is possible for angle theta to be in. So right away we're going to use the cast rule. And we're being told that cosine is negative. So if we look at the cast rule, we know that cosine is positive here, and it's positive where all of them are positive here, which means it's going to be negative in the other two quadrants. And that's what they're asking us, where's cosine negative? So then we just need to know how to number the quadrants again. So again, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So determine which quadrants it is possible for angle theta to be in. Since the cos of theta is negative, it's quadrants 2 and 3. Draw a labeled diagram for each possibility. So we have to draw two diagrams. We can't put them both on the same one. It's a question I get every year. Two separate diagrams that have to be labeled for two separate possible values of theta and also the different values of the ratios. So in each diagram you want to label the x and y axis. And then you want to draw a terminal arm. We decided in quadrants 2 and in quadrant 3. So there's quadrant 2, and now here's one in quadrant 3. In this case, the quadrant 2, this would be theta, and in this case, in quadrant 3, this would be theta. We also want to pick a representative point along the terminal arm and draw in our triangle. Same thing with quadrant 3. It's a right angle triangle in each case. And then remembering that we're given that the cos of theta is negative 7/25. R is always positive, so the negative is going to go with the 7. Cos is x over r. That will help us fill in two sides for each of our triangles here. So negative 7 and 25, x over r, and then negative 7 and 25 here. But we still have to figure out the y value to complete our labeled diagrams. So we're going to use Pythagorean theorem. R squared equals x squared plus y squared. 25 squared is negative 7 all squared. Make sure you put the brackets. So y is going to be positive or negative 24. And then it should depend on the diagram. So in this case, positive 24 makes sense. And in this one, negative 24 makes sense. Okay, and then part C says find the possible values of the cosecant of theta. So we would need to have memorized our formulas and know that cosecant theta is r over y, or the reciprocal of sine. And then we would want to look at each diagram. So if we look at this diagram, the cosecant of theta is 25 over 24. And if we look at this diagram, cosecant of theta is 25 over negative 24. And then we can make a concluding statement then. Therefore, the cosecant of theta is either positive or negative 25 over 24. Okay, next question. Given that the tangent of theta is negative 2, find possible values of cos theta. So again, a hint in the question because they want more than one value. It's gonna involve two diagrams. So we're gonna do the cast rule again. So in this case, tan is negative, but the cast rule tells us where things are positive. So tan's positive where all of them are positive, and where tan is positive, which means it's going to be negative in the other two quadrants. Okay, that's quadrants 2 and 4 that we're going to draw our labeled diagrams with our solution. So the diagrams are a huge part of the solution and worth a lot of marks, so make sure that you know how to draw them. And don't forget to label them completely. So quadrant 2, and quadrant 4, remember, theta is always drawn from the positive x-axis to the terminal arm. That never changes. And you always make your right angle triangle with the x-axis. So being told that tan theta is equal to -2 is being told the y value divided by the x value. So we can fill a 1 in there. But since both x and y could be negative depending on the quadrant, you have to put the negative sign where it makes sense. So for instance here, if x, it wouldn't make sense for x to be +1 if we're going left from 0, 0. So the negative must be with the x in this case and the positive with the 2, -1, 2. But in quadrant 4, it makes sense for x to be positive going to the right and the y value to be negative. R is always positive, so we can use our Pythagorean relationship to figure R out. So we have r squared equals 1 squared plus -2 squared, or the other way around. So we get r is the square root of 5, always positive. So now we have our two diagrams labeled completely. And then we want possible values of cosine of theta. So from this diagram, we get that the cosine of theta is x over r, so it would be -1 over root 5. And from this diagram, though, we would get that the cosine of theta would be +1 over root 5. And then we can do a concluding statement. Therefore, cosine of theta, so the possible values are positive or -1 over root 5. Okay, given the secant of theta is 4 over 3, in which quadrants is it possible for the terminal arm of angle theta to lie? Okay, so the first thing I would do when given a reciprocal trig function is rewrite it in terms of one of the primaries. So we know sec and cos go together, but if I change sec theta to cos theta, I have to flip the fraction and make it 3/4. But in either case, it's positive, so the cast rule can help me tell. So I'm looking for where is cosine positive. So cosine's positive where all of them are positive and where cosine is positive. So in which quadrants? That's quadrants 1 and 4. Draw a labeled diagram for each possibility. Okay, so A we just answered there by doing the cast rule. B we're gonna draw a diagram for, or two diagrams for. So quadrant 1 and quadrant 4. Label our x and y axes. Quadrant 1. quadrant 4. Theta. Theta is a reflex angle between 270 and 360 in the case of quadrant 4. Make my right angle triangles the x-axis. And then the fact that cos theta is 3/4 is telling me the x value over the r value. So in each case, my x value should be +3, and my r value should be +4. And to complete our drawings, we need then the y value. So we use Pythagorean theorem. So our r is 4, x is 3, so we get that 7 is y squared, or y is positive or negative the square root of 7. So in this first picture, it makes sense for it to be positive square root of 7, and this one, negative square root of 7. And remember, we leave it as square root if it's not a perfect square, because we want it to be exact. All right, so we've done our labeled diagram, labeled theta in each case, all 3 sides of the triangle that's associated with it, the x and y axes. So we're on to C. Find the possible values of tan theta. So from our first picture, tan is the y value over the x value, so √7/3. And from our second picture, negative √7/3. So then we can say, therefore, tan theta is either positive or negative √7/3. And then D. So find the possible values of angle theta. So we can see theta is going to be between 0 and 90 if it's in the first quadrant, and then between 270 and 360 if it's in the fourth quadrant. So we need to find alpha, but in the case of the first quadrant angle, it's the same as theta. But it's also going to be, so this is alpha, but this is also going to be alpha because we've got the same 3 sides of a triangle, 3, √7, and 4. And then this one would also have the same sides. I'm drawing it twice because this is the first time we've seen it, but you have to realize that it's the same triangle. Alpha is just drawn here, but you can see the side opposite alpha is √7, the side opposite alpha is √7. The side opposite the right angle is 4, the side opposite the right angle is 4, and the adjacent side is 3. Okay, so they're really the same triangle. You only need to draw one of them to figure out what alpha is. So if I don't want to use the √7, then I would use cos alpha is 3/4. So alpha is the cos inverse of 3/4, or approximately 41.4, so 41 degrees. So that means for quadrant 1, theta is actually 41 degrees. But for quadrant 4, theta is going to be 360 minus alpha. I need an approximate there. Or approximately 360 minus 41, 319 degrees. So the possible values of angle theta to the nearest degree are 41 degrees and 319 degrees. Okay? Next question. So given that the cosecant of angle theta is -3/√5, find 2 possible values of theta, and then it says where theta is between 0 degrees and 360 degrees. Include labeled diagrams with your solution. All right, so similar strategy to question 3. The first thing I would want to do if I was given cosecant is change to the primary trig ratio sign, and then flip this upside down. I'm going to leave the negative sign on top though. And we know that that's going to be the y value over the r value. And then I can use the cast rule to figure out what quadrants it's possible to be in. So we're looking where sine is negative. We know sine is positive here and here, according to the cast rule, which means that sine is going to be negative in the lower two quadrants, quadrants 3 and 4. So it tells us to include a labeled diagram for each with our solution, which is going to be 2 possible values, so we need 2 diagrams. There are x and y axes labeled. And then terminal arms in quadrant 3 for one of our diagrams. And a terminal arm in quadrant 4 for our other diagram. So theta can be between 180 and 270, or it can be between 270 and 360. Make our right angle triangles with the x-axis. In both cases, the y value is negative root 5 because r is always positive, and it makes sense with our diagrams. And our r value is 3. And then we can use Pythagorean relationship to get our x values. So first of all, any number squared is going to be positive. When you square a square root, it undoes the root. So if we square root both sides, we get that x is positive or negative 2. So then it's up to us to figure out which diagram x being positive 2 makes sense with. That's this one here. And which diagram x being negative 2 makes sense with. This one here. So given that cosecant theta is negative 3 over root 5, find 2 possible values of theta. So we haven't found any values of theta yet that are between 0 and 360. Include labeled diagrams. So we've got to the labeled diagrams picture now. But now we're going to want to get alpha. And alpha is going to fit here and here, both places. So again, we want that grade 10 triangle with all the sides being positive. So I've got 2, root 5, and 3. I could use cos of alpha equals 2/3. Alpha is the cos inverse of 2/3. Or approximately 48 degrees. And then we know for quadrant, if I move this up just a little bit, for quadrant 3, theta is going to be 180 plus alpha, and for quadrant 4, theta is going to be 360 minus alpha. So then my answers are going to be approximate because alpha was approximately 48 degrees, so 180 plus 48, so approximately 228 degrees, or 360 minus 48, or approximately 312 degrees. So those are our 2 possibilities for theta. And look, they're both between 0 and 360. We figured them out using alpha and what we know about how to get theta in quadrant 3 and quadrant 4. Okay, and our last question for today's lesson, our last example. Given that the cotangent of theta is the root of 6 over 5, find the possible values of theta where theta is between 0 and 360. Include labeled diagrams with your solution. Okay, so again, it's a reciprocal trig ratio, so we want to change it to a primary trig ratio. Use the cast rule. We want to know where tan is positive. which is in quadrant 1 and quadrant 3. And we have to include labeled diagrams with our solutions. So quadrant 1, quadrant 3, so theta could be between 0 and 90, or between 180 and 270. And we're told that tan is 5 over root 6, and we know tan is the y value over the x value. So in the first quadrant, the y value is 5 and the x value is root 6. But that does not make sense in quadrant 3, because we know the x value would have to be negative, and so would the y value. But if you think about that, negative 5 over negative root 6 reduces to positive 5 over root 6. So you have to be really careful when you're doing tan there and you're working with quadrant 3. Tan is positive because a negative divided by a negative is positive in quadrant 3. Okay, so you need to have these negative signs here in order to have correctly relabeled the triangle and to get your solution correct. Okay, so r squared equals x squared plus y squared. It's going to help us get the r value, which we know is always positive. Oops, this is just 6. Root 6 squared is just 6. So r squared is 2531. Which makes r the square root of 31, always positive, and it's not a perfect square, so we leave it as square root of 31. Okay, so we've got our labeled diagrams now. Now we have to get our angle. So just going with our quadrant 1, we can use tan to get theta, which is also alpha in quadrant 1. And it will be the alpha in here as well. So if we go tan of alpha is 5 over root 6. Alpha is going to be the tan inverse of 5 over root 6, which is approximately, so make sure you can enter that into your calculator effectively. So you might have to do 5 divided by the square root of 6, or 6 square root, and then equals, and then shift tan, or second tan. However you do it, you should be able to get 63.899, so approximately 64 degrees for alpha. So in quadrant 1 then, quadrant 1, that means that theta is, quadrant 1, that means that theta would be approximately 64 degrees. But in quadrant 3, theta is going to be 180 plus alpha, or approximately 180 plus 64, 244 degrees. So there's our two possibilities for theta, 64 degrees in quadrant 1 or 44 degrees in quadrant 3. All right, the success criteria for this lesson are that you can use the cast rule to determine which quadrants it's possible for the terminal arm of an angle to lie in. And then our second one, given a trig value, example that the tan of theta is -3/5, you can use the cast rule to determine two possible values for each of the other trig ratios, or two possible values for angle theta.